Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za. The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Chris, good morning. Lovely to chat to you again.
Morning.
Wonderful. Okay, now there is a story about breastfeeding. I'm very, very nervous going there because I think our listeners will think I'm making this up because of my condition. But you are saying that this is scientific and there's news about breastfeeding and climbing the social ladder. Tell us about it.
In the journal Archives of Diseases in Childhood is a very big study, first of its kind in the world actually, where they've been able to do this. It's from Amanda Sacker and her colleagues there at University College London. And what they have done is to take two extremely big cohorts of people. One group of 16,000 plus people born in 1958, a second cohort of equivalent size born in 1970. They then ask, what social class are the fathers of those children at that time? They then go back to those kids when they're 33 years old and working themselves and ask, what social class are they in now? And then they say to the mothers, did you breastfeed these children? And if so, for how long? And when they then do a comparison, the results are stunning. Because it turns out that for children that were breastfed, and particularly breastfeeding for a long period of time, more than 4 weeks, not just a one-off, they find that the breastfed kids are 25% more likely to have climbed the social ladder compared with their father's social class, and they were 20% less likely to have descended the social ladder compared to their starting parental social class, compared with those in those groups who were not breastfed. And they say this relationship looks what we call causal because effectively they've compared two different cohorts born at two different times, and the effect holds strong regardless of which social class a person starts in. So it's not just lots of rich and well-informed people in the top social classes all breastfeeding and then begetting more kids who all end up further up the social scale. It is right across the social spectrum in both birth cohorts, both analysis periods. So the conclusion they draw is that breastfeeding does appear to confer benefits in terms of a child bettering themselves in life. They don't know exactly why, because that was outside the scope of the study, but they do speculate that it could be that the enhanced emotional ties that occur between a breastfed baby and its mother might make the infant more resilient against stress. And it may also be that the nutritional benefits of breastfeeding, because there are certain things that can be obtained from breast milk, fatty acids that are good for brain development, chemicals that select for microorganisms in the gut and therefore affect the supply of nutrients to a developing child and therefore make a healthier adult. Those may all play a role, and that needs to be looked at next.
I love the story, Chris. In fact, it's my favourite story since we started this interaction with you. But Chris, is it possible?
You should be emphasised, though, Reedy, that this doesn't apply to adults, okay? So any adults out there with any ideas of bettering themselves by resorting to breastfeeding, that's not going to work.
Thanks for reminding us of that. Our lines are open for you for The Naked Scientist on 021 446 0567 011 883 0702. David in Northcliffe, hi.
Hi, Rudy. Hi, Chris. The glaciers around the world are shrinking. Now, I can only assume that glaciers are formed when snow falls. So how much snow must fall for the glaciers to start growing again?
Hello, David. You're right that ice sheets and glaciers are in a dynamic equilibrium, usually. So in other words, they melt a little bit seasonally, but then in the other colder part of the season, the amount of ice is added to again because more snow falls or more ice forms, and that replaces what they lost, and therefore the overall amount stays about the same. If you shift that balance, so you're forming more ice than you take away, then the glaciers grow, and that's what happens when we go into an ice age. If you reverse that trend and you erode more ice because the warming exceeds the cooling, you lose the ice.
Yes.
And to put some numbers on this, scientists do have some pretty clear ideas now, because there is an experiment that's been going on for about 10 years or so. It's called GRACE, And GRACE is a pair of satellites that are going around the Earth, and they are communicating with each other by what's called interferometry. They're sending a beam of laser light from one to the other, and as one satellite is ahead of the other, it is feeling the Earth's gravitational force based on what is directly underneath it. And if one satellite goes over a patch of the Earth's surface that is slightly more gravitationally active, because there's a lot of ice on it, for example, then it will accelerate away from the following satellite transiently, and this will stretch the beam of light a little bit, and the following satellite can see that, and therefore you can work out what the gravitational field profile is of the Earth's surface below. And this has enabled them to physically weigh Greenland, or more specifically to weigh how much ice is on Greenland, and do this year on year to see how that mass is changing. And the trend is quite worrying, because the amount of mass being lost from Greenland shows that it's losing in the order of hundreds of cubic kilometres of water every year. So huge amounts of ice are being lost and therefore not replaced. And so to answer your question, how much would you have to put back? Well, you'd have to correspondingly put back the amount that's being lost plus the amount that's been lost year on year on year. And there's enough ice on Greenland to put sea levels up by quite a high amount if it all goes.
All right, our lines are open for you, 021 446 0567, 011 883 0702. We are taking your SMSs on 31702 and 31567. Naked Scientist, what happens when our eyes itch? What actually happens?
Well, I tell you, my eyes have been itching really because we've had a late onset to summer in Britain, because the weather was so cold at the beginning of the year, and consequently lots of plants have all started coming into bloom or having their flowers all at once and quite late. And so we've got a big surge in pollen all of a sudden, and lots of people are having hay fever symptoms, and that includes itchy eyes. And what is going on when you have itchy eyes, or actually any part of your body really itching, is that pollen grains or some irritant get into the eye and they interact with your conjunctiva, which is the layer which is inside your eyelids and onto the front part of the eye apart from the clear bit that you see through. And in that conjunctiva are cells called mast cells, and those mast cells are loaded with histamine, and they're there like policemen. They're supposed to be looking out for bad guys or infections trying to come in, and when they detect one, they discharge this histamine. It comes out of the mast cell and it goes on to nerve cells that trigger itch and signals them, hey, pay attention, this is something bad in this part of the body. They also make blood vessels open up and become leaky so that tissue also swells. And when someone has an allergy to make them have itchy eyes, their mast cells have got a kind of antibody called IgE on them. And this IgE antibody, instead of recognising just bad guys, starts to recognise things that we should ignore, like pollen. And so it discharges the mast cell when it shouldn't. And that's why your eyes then itch. And it's the same process in skin, actually. When people have eczema, they've got some kind of allergen, something they're allergic to, going into the skin and triggering off an immune allergic reaction and triggering itch-sensitive nerve cells, which then convey that itching sensation back to the spinal cord and then up to the brain.
Let's go to Isaiah. Is it Isaiah calling us from Edenvale? Good morning.
Yes, how are you ready?
Good.
Thank you. I just want to know about the yoga. I love yoga so much and I'm practicing that. But there was some point where after doing that, I find that I'm losing myself. I can't think normally. I can't do my usual stuff in a normal way. And someone told me that there is something called the center of your being, that as you're doing those positions, you shift it. And after doing the exercise, you must also normalize yourself. I just want to know from the doctor what is actually happening when someone does the yoga. And
hello. I don't practice yoga, I must admit. Maybe I should. It'd probably be very good for my constitution. But I think the point about it is that you're doing something physical and you're also doing something mental. And you put the two together and you end up with an experience which is health beneficial, because it makes you distance yourself from all of the mundane things we usually worry about during the day. Think about things more clearly by relaxing and focusing your mind on a range of things that aren't the trivialities. I'm not sure that there's any evidence that this causes any kind of long-term disbenefit, but it certainly makes people feel more relaxed. And if you're more relaxed, then this tends to have benefits for your blood pressure. It also has benefits for your risk of getting very stress-related disorders and improves your mood, so you're more likely to get on better with other people as well, so you'll have a happier day.
Keep on doing your yoga, Isaiah. It can only be good for you. Let's just take your calls. Let's take a break and then we'll come back with more of your calls.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
14 minutes to 10 o'clock. We're taking your calls on 021 446 0567 011 883 0702. Ruben in Roodepoort. Hi.
Hi, Rudy. Good morning, Dr. Chris. My question is on solar sails. The principle behind solar sails is that it is propelled by light. Now, light consists of a photon. Photons are massless. My question is, what aspect of light actually causes the solar sail to be propelled?
Hello, Ruben. What a lovely question. So you're quite right to question the fact that how can light, which is going at the speed of light, have any mass or momentum then? Because if it's going at the speed of light, nothing can go at the speed of light if it has mass. And so how can it give a push to something if it doesn't weigh anything? It seems paradoxical, but actually light does actually work. Let me explain how. So when we have these solar sails, you have a big collecting area, so a surface, and you're basically impacting photons, light, onto them. Light is massless, but it does have energy. When it interacts with a surface and hits something, it stops moving and it releases the energy onto that thing and therefore has energy at that moment, and it can impart that energy as momentum to the thing it hits. So although it doesn't have mass when you measure the mass of a photon, because it's energetic, it can convert the energy into mass, and therefore it does have a momentum when it stops and hits something.
Ruben, does that answer your question?
Yeah, it leads to so many more questions.
Okay, I'll give you a chance to ask one more.
Thank you. If the mass is zero, then momentum equals m times v. If the m is zero, what is your momentum equal to then?
Yeah, well, that's the point, that when it stops, it does have that energy and it interacts with the surface electrons of the thing it hits. Because when light goes into a surface, let's take a mirror for an example, or if you look at a piece of paper, it's white, it's reflecting all of the different wavelengths of light. Yes. The photons, the light, has come in, it has hit the surface of the material, and it has interacted with a cloud of electrons around the atoms which are on the surface that is reflecting the light off. Those electrons soak up the energy and they move themselves. They have more energy. They then fall back to their starting position, reflecting that light, but effectively regenerating more photons which come back towards your eye. And in the process of doing that, there is a nudge, a push, being given onto the thing that's hit by the light by the photon striking it, because you're making the electrons alter their behaviour in the thing that's been impacted.
Thank you very much, Ruben. Thanks indeed for lovely questions. I have an SMS here from somebody who says she's right-handed but left-footed. How does that happen, Chris?
Well, I'm not an expert on how sort of footedness goes with handedness. Yeah. We know that hands definitely are strongly associated in terms of which hand you prefer to write with, and which you would therefore judge to be your dominant hand, with which side of your brain is your dominant hemisphere, and therefore where language is located. Let me clarify. So everything on the right side of my body is controlled by the left side of my brain, with a few minor exceptions, and vice versa. And if you look on the left side of my brain, because I'm right-handed, you will find that the parts of the brain that control my language, how I'm speaking to you now and how I'm listening to people's questions, that's also going on in the left side of my brain. And the two seem to go hand in hand, excuse the pun. Mm-hmm. So the left side of the brain has language in it and corresponds to right-handedness in 80 or 90% of the population. We think it's always been that way because we can find evidence of cave art going back tens of thousands of years. There's lovely studies been done in France, actually, where they were showing cave art, which was people blowing through a blowpipe at their hand pressed against the wall of a cave. And if you think about it, if you were right-handed, you'd probably hold the blowpipe in your right hand and blow it onto your left hand, because then you're doing the accurate bit with the hand you're best at using, and therefore you would expect that the majority of the pictures on the cave wall are going to be left hands if the majority of cave people were right-handed, and that's indeed what you see. So we think that this is the case for a long time. How that relates to which foot you prefer using, I don't know the answer to that. There is a very good book which is by Chris McManus. He's from University College London. He won the Aventis Book Prize for writing Right Hand, Left Hand about 10 years ago, and it's one of the best and most enjoyable science books I've ever read, and it looks at both handedness of people, but also looks at handedness of molecules and asymmetries in the universe around us. It's a really fascinating read, and he does sort of touch on that subject, so it might be worth people taking a look at that book if you want to read a bit more around the subject.
Let's go to Claire. Claire in Tamburskloof. Hi.
Oh, good morning. This is a simple one in comparison. A friend of mine adamantly maintains that he has absolutely no sense of smell. Yet, he says, he can taste. He can distinguish between different wines and different foods. Is this possible?
Hello, Claire. You're right to smell a rat. Another bad pun. Because the vast majority of what we're calling taste is actually smell. And the reason for this is that when you put food into the mouth, if you stop people from smelling by holding the nose or preventing air from flowing through the nose, people can discern only a small number of different experiences. Bitter tends to dominate, saltiness, sweetness, the fluidity of food, fattiness, they can experience probably by just how the food runs around the mouth. And then there's this sort of meatiness flavour, this umami flavour as well. That's pretty much it. The rest of the enjoyment of a delicious wine or a lovely plate of food is all smell. You put this food into your mouth, and the warmth and the dampness from your mouth volatilizes or evaporates chemicals in the food, and they go up the back of your throat, into the back of your nose, and at the bridge of your nose is your olfactory epithelium, which is the site where you do smelling. And you experience those smells coming from within, and because you're experiencing them at the same time as having this experience in your mouth of the food being there, we all assume it's coming from our mouth. But the vast majority of that taste experience and that taste explosion is smell. And so if someone hasn't got a sense of smell, food is really very bland to them, doesn't taste nice, it's a poor experience. And this is why a lot of old people often complain that they're not liking their food very much, and they tend to eat too little, because smell does decline with age. And as a result, the experience and enjoyment of eating also can decline with age. And consequently, people as they get older tend to like stronger flavoured things, especially spicy things, because this does restore some of that stimulation that food used to give them and makes it more enjoyable again.
Thank you very much, Claire. And is it Manny in Roodepoort? Hi.
And really, just a quick question. People tend to get more hairy as they age. Men lose hair on their heads, but they get hair on their back. And ladies get more facial hair as they age.
Oh.
Now, if this is testosterone related, testosterone decreases as you age. Why does it happen?
Yeah, it's a really good point. I'm going to speculate because I don't know the precise answer to this, but I believe that the reason why this happens is that although your peak testosterone levels do fall with age, you have to think of it in terms of the overall amount of testosterone exposure that a tissue has seen over a person's lifetime. So you're right, as you get older, your overall level of testosterone is a bit lower, but the tissues which are seeing testosterone have seen a lifetime's worth. So even though only a little bit is being added as you get older and older and older, it's actually adding a little bit to a lot that's already been there. And so the tissues respond to the lifetime dose of testosterone rather than just the one-off, at that moment in time, level of testosterone. And that's why you get the same changes in both men and women. Women have testosterone as well. It's responsible for their sex drive, but they have it at a much lower level to men, and therefore their tissues are correspondingly more sensitive to it.
Chris, I don't know if you've got time for this, but I think it's a great question. Why is a rainbow shaped the same way as the atmosphere? I understand the prism and color, but why the shape?
Okay, well, it's because the light which is reflecting from raindrops, because when you have a rainbow, the sun is shining at usually a dark background. You've got rain clouds. The sun goes into the rain. It goes inside raindrops. The wavelengths of light, which make up white light, are all of the different colours. They bounce off the inside back surface of raindrops, reflect out of the raindrop and come back towards you. And they're not just an arc, they're actually a cone. So if you can imagine a point of light, the light spreads out like a cone shape, but the cone of light also spreads upwards and downwards, and therefore the bit of light that gets to you is the top half of the cone. The bottom half goes into the ground and you can't see it. So the shape is driven by the fact you've got a cone of light coming out of a raindrop, or lots of raindrops.
Thank you very much, Chris. Let's speak again next week.
Thanks, Rudy, and thanks, everyone. Great questions. Have a good weekend.
Absolutely. I loved it. And don't forget that this conversation with The Naked Scientist will be available as a podcast. And you can also follow The Naked Scientists on Twitter. It's simply @NakedScientists. It's a plural. @NakedScientists. And also their website address is www.thenakedscientists.com.